Okay, here we go, guys. So, police measure the speed of cars passing a particular point on a motorway. Now, the random variable x is the speed of a car. So here we define x as the normal distribution of mean 55 miles per hour. So right off the bat, before I even look at a and b, firstly, let's write down the distribution, which is x is normally distributed with mean 55. Now this 20 came from a later question, which is over here. It has a standard deviation of 20. And it's okay, you can put that there because it doesn't affect any question either way. Now, let's start A. So firstly, draw a sketch to illustrate the distribution of x. Label the mean on your sketch. So first things first, this is just a standard normal distribution, so get your bell curve out. So draw a nice simple bell curve and then draw a line cutting through the center, and that will be your mean 55. And that's it, you're done. This extra information is for part B, so you can ignore that. So it's just the red part only. Easy 2 marks. Now, next one. The speed limit on the motorway is 70 miles per hour. Now, car drivers can choose to travel faster than the speed limit but risk losing being caught by the police. So this is indicating that if you go faster than 70, you'll be over here. Now, the distribution of x has a standard deviation of 20, so we can put 20 there. So sigma is 20. Now, B, find the percentage of cars that are traveling faster than the speed limit. So all we care about is that we want to find the probability that x is greater than 70, because 70 represents the speed limit and anything greater is, of course, the region of interest. This is, of course, the resolved answer. So when you do probability x greater than 70, we have to instantly convert this to the z form. Now what I did here is that I did firstly, to convert to z, it's going to be the following. Let me just quickly get my pen. It's going to be 70 minus the mean, which is 55, over sigma, which is 20, and resulting this you should get 0.75, and that's it. Now this equals to 1, and then the thing of this question is that once you have this z value here, you realize that the table value only records the left hand side, so probability z less than equals z, so we want the left hand side of the distribution. And to get this, we have to pretty much reflect this. So if it's greater than, it'll be 1 minus the less than counterpart. So z greater than 0.75. On the distribution, it will look a bit like this. So instead of the mean being 55, on the z it'll be 0. Instead of 70, it'll be 0.75. So this is the region of interest. So we want to do 1 minus the left hand side, the white part. This will give us this area. So we do 1 minus the left side. And now we can get the table value because the left side is in the table. So let's have a look at the table then and see how we get this result. So 0.75 here is over here. And this gives us a table value, a probability of 0.7734. Plug in over there, and then if you 1 minus this, you get 22.66%. Or in the mark team, you can just keep it 22.7%. That's it. Now let's move on. So the fastest 1% of cars will be banned from driving. Okay, so fastest 1%, so you're talking about literally the end points of the tail. Okay. Now C, show that the lowest speed corrected 3 sim figures for a car driver to be banned is 102 miles per hour. Show you're working clearly. Now, in this case, they already gave us the results 102. So what I did is I just called it D. And I realized if you want to be at the top 1%, you have to be at the edge of the tail. So you imagine we did a line over here and just called it D. That's exactly what we're trying to find out. So just line D, we'll find that little small area here, which is equivalent to 1%. Okay. So you can just say probability x is greater than D, and that equals 1%. And now all we do is convert this to the z form, which is over here. So I did D minus the mean, which is 55 over 20, and all of this must equal 1%. Now all we do is look at the table for the grade, because now this is in the graded form, we can use the percentage tables. The percentage tables lets us check that out, which is here. Okay. And over here we can just simply find 1%. And here's 1%. It's literally 2.363. So this means that the value z here, the area, or this value z, is now equivalent to 2.3263. So this means we can just equate this to here, and now we can just calculate for D. So that's it, guys. I mean, this is it. So when you make all this equal to 2.3263, you just simply solve to find this value. So just in case you're not sure, it looks a bit like this. So D minus 55 over 20 equals 2.3263. Now you just times 20 across, add 55, and boom, 102 miles per hour. You're in the top 1%. Yeah, not bad. Ooh, yeah, so actually I'm fasting today, guys, so that's why I sound a bit knackered. But I hope you're enjoying it so far, because we've got one more to go. Well, and more after that. Now, next one. So car drivers will just be given a caution if they are traveling at speed m, such that, and this is the probability distribution, where x is between 70 and m. So looking at this graphically, I mean, we know that the mean is, what was the mean? The mean was 55, so that's the center bit. So center bit is 55. So we know that 70 is above the mean, and we're trying to find some area between 70 and m. Okay, so that's how it looks visually. So it's always good to draw a graph. Now, to work out this area and to make it into simple probabilities like these, think of it like this. We want to find the area which is less than m, so literally the whole region less than m, minus the region less than 70. And what that means is that now this part cuts off and you're just left with this small interval here from 70 to m. And that's essentially this. Probability x less than m all the way across minus the first 70 will give you that small region. And of course, this is all equal to 0.1315 because that's the question. Now, calculating each one. So the tip is to always calculate one of them, the numbered one, solve it and then put it to the other side and then evaluate and solve the m version using the tables. So probability x less than 70. Well, we have this from part A. It's over, where is it? It's, I'm lost. Yes, actually it's on part B. We found probability x greater than 70, so it's going to be, and we said it's 22.66. So the answer is going to be 0.7734 because that's the left hand side. So less than 70 be 0.7734. So that's this result. Now plus this to the other side, you can get 0.9049. And all you have to do now is convert this with x less than m to the standard normal, the z form. So it'll be z less than m minus the mean over sigma, standard deviation, again equal to the same probability. Now finally, all we need to do is find what is the value that corresponds to a probability of 0.9049. So on the tables we go. Let's find 9049. So use the big table. So 9049 is here, and we can see that the equivalent z value is 1.31. So this means all of this area equals 1.31. And just like the previous one, we just now say that m minus 50 over 20 must equal 1.31. And we solve it and we get m equals 76.